Chadron Wellfield, Electrical System Upgrades, Scott Roberts Electric Incorporated and TTG Enterprises Incorporated, joint venture. Master Craftsmen Superintendents Kevin Morris and Scott Roberts. Craftsmen, Scott Collins, Christopher Reed, Jeff White, Charles Vinton, and David Feltz.
In March of 2015, Roberts Electric and TTG Enterprises were tasked with upgrading the electrical control systems for the city of Chadron's Wellfield. The work included a total rewire of the transfer pump house and the rewire of 4 of the 5 well pump houses. 2 75 horsepower, 200 horsepower, and 150 horsepower pump were to be fitted with variable frequency drives. The electronic soft starter for the 400 horsepower pump was reused. Properly accessible and sized switchgear, proper lighting both interior and exterior, and an Ethernet-based control system were to be installed. The desired work replaced a base electrical system originally installed in 1969 with numerous add-ons and patches during the period in use. The original lighting was so poor that flashlights and headlamps had to be used to perform work even with the lights on during the day. There was a lack of GFCI receptacles, so having a pipe burst could be hazardous to your house when trying to repair it. There was not sufficient clear working space around the electrical equipment to meet modern work requirements, and the existing controls and switchgear could not be serviced properly without placing workers at risk. The photos of the original layouts in the well pump houses had to be taken from the outside because you couldn't get a shot of the electrical equipment from the inside. Work began in the transfer pump house by removing and replacing the existing 800 amp, 480 volt switchboard, relocating it tighter to the existing wall. The 400 horsepower soft start was relocated and connected to a properly sized circuit breaker. The new 150 horsepower variable frequency drive was installed along with the new low voltage transformer and a 120/240 volt circuit breaker panel. The existing control panel was relocated from the middle of the room where it blocked access to the switchboard to the exterior wall as well. By relocating the electrical equipment, we were able to free up about 200 square feet of floor space to work in. One of the best improvements was the installation of the new LED strip light fixtures, turning night into day and making it easier and safer to inspect and service equipment while using about 1/3 of the energy of the original pair of 150-watt incandescent light bulbs. The pump houses were so small that in order to meet the code requirements for clear working space, the city had to add a room for each one of the well pump houses to house the new well pump control panels and pump variable frequency drives. Once the city could shut down a well for rehabilitation, the existing electrical equipment, piping, and wiring were removed and the new installation began. The new electrical equipment, control panel, variable frequency drive, line filter, and reactor, transformer, and lighting arrestor were prefabbed into a modular system for quick field installation. The original single 150-watt incandescent light bulb was replaced with LED strip fixtures as well, with an additional strip in the new electrical room. Not only were the well controls upgraded to new programmable controllers with a touchscreen interface, an Ethernet-based radio system was installed to provide a higher degree of system reliability and security. In all locations, proper signage for electrical hazards were put in place to further enhance the safety and comply with work safety codes. The time to complete the work at the transfer pump house was 4 weeks, and each of the well pump houses was 2 weeks. Each stage was coordinated with other well work that the city had scheduled, and the city saw no loss of water availability during the project. With the new well field systems in place, future plans include the use of man-down equipment, and an Ethernet link back to the city water treatment plant would give quick access for drawings and equipment manuals for on-site service. Another benefit of this project was the city saw an overall reduction in power usage of 7% during the 2015 season, with just 150 horsepower variable frequency drive for the whole season and well number 3 for about half of the season. The overall savings in power use for 2016 with both wells running have not been calculated yet, but I am sure it will be impressive. Once the city completes the scheduled rehabilitation of well number 5, they will be able to adjust flows so that only one well and the 150 horsepower transfer pump run, providing an even greater savings. The functionality and reliability improvements aside, we electricians appreciate having the proper work clearance and sufficient lighting to be able to work on high-energy circuits safely.